Hi everyone. In our Zoom session the other day, we talked about pressure and volume changes and getting air into the lungs and out of the lungs, right? But there's more than just pressure volume changes that affect this. So I want to talk about that a little bit. Let's talk about pulmonary ventilation and getting the air into the lungs and what three factors affect that. First, airway resistance. Second, alveolar surface tension. And lung compliance. All right, so airway resistance. Do you remember in blood vessels, what was the key factor in resistance? It was vessel diameter, right? So here we have bronchioles instead of arterioles, and we have smooth muscle around our bronchioles still. You can see I drew it in here. And so when the smooth muscle constricts, we have bronchoconstriction. When it relaxes, we have bronchodilation. And if you remember in blood vessels, when it constricted, that was a sympathetic nervous system. But it's different here because think about it. When you are in fight or flight, do you need more oxygen or less? You need more, right? Excuse me. So sympathetic nervous system here is going to cause bronchodilation to get more oxygen to your body. Bronchoconstriction will happen from parasympathetic nervous system or inflammatory mediators, which is important to remember. If you have an inflammatory reaction, you can have bronchoconstriction, and that's not necessarily a good thing. All right, alveolar surface tension. We talked about this in our Zoom session the other day. How we have water, oxygen, and two hydrogens. It's a polar molecule. If you want to look this up in the textbook, it's back in chapter 2. So it's a polar molecule, and I drew these little dashes here. Those are the hydrogen bonds. What the hydrogen bonds do, they hold it close. You get that surface tension. You see surface tension in water, right? When you pour water. Remember doing in lab the experiment where you took a penny and you dropped water on it? And you could see that it held together more. But then what do you do with a penny? Did you add a little detergent? So what happens is, in our lungs, if we make a surfactant to break these polar bonds. And why? Well, here's a lung with surfactant. They're made by type 2 alveolar cells, and it breaks the hydrogen bonds. What happens if we don't have that? You see how it's kind of shriveled in? It's been pulled in. So the hydrogen bonds are strong enough and the alveoli are small enough and thin enough that surface tension of the water will start to collapse it, especially when you exhale. So you can get alveolar collapse without any surfactant, made by those type 2 alveoli cells. All right. The third factor is lung compliance. Remember we talked about vessels being compliant? So here we're talking about distensibility, not elasticity. Remember in our last session we talked about elasticity as I can pull it out and it'll snap back. But distensibility is the ability to distend it, to pull it out. And it's the same tissue properties, the elasticity of the tissue. The same tissue properties allow for distensibility and elasticity. But if I can't pull my lungs or my chest wall out, then how am I going to have that pressure volume change? I can't increase the volume to decrease the pressure. All right, so chest wall and lungs, it's the stretch, the distensibility. Here we see lungs and chest wall. Both need to be distensible. Otherwise, you won't have that volume change, to have that pressure change, to have the air rush in. Does that make sense? So what are the three things? Airway resistance, alveolar surface tension, lung compliance. What are some key terms that I want you to know or write if you're writing an essay? I'd want to see bronchodilation and bronchoconstriction. I'd want to see smooth muscle. I want to see that water is polar. It forms hydrogen bonds. That surfactant breaks the hydrogen bonds. And you can get the alveoli can collapse. Over here I want to see distensibility. And I want to see chest wall and lung as well. But does that make sense? They're all things that, when you think about it, they make sense, right? You need the airways to be open in order for air to get through. You need the sacs, the alveoli, to be open, or they're not going to hold much air. You won't get much gas exchange. You need the chest wall and the lungs to be distensible, or you're not going to have that volume change, to have the pressure change for the air to come in. All right, so these are the three other factors that affect pulmonary ventilation. Thanks, guys.